Good morning, everyone. My name is Riya Chawla, and today I'm here to talk about assignment 2 for COMP6210 Big Data. This is my code. So let me begin. The provided code implements an R tree data structure and performs range queries on the points stored in the tree. So here's a breakdown of the code. The first one is called the R tree node class. It represents a node in the R tree. It has attributes such as maximum capacity, list of points, a list of child nodes, a parent node, and a bounding box that contains all the points in the node. The next class is called the R tree class, which represents the R tree itself. It contains methods to insert points into the tree, query the tree, and adjust the tree structure. So I've defined a couple of functions within this class, and let me tell you about them as follows. So the first one is called the area increase, which computes the increase in area of a bounding box if a given point is added to it. Next one is called the range query. It accepts a query, returns the count of points that lie within this rectangle. Third one is called insert. So this inserts a new point into the R tree by choosing the appropriate leaf node for insertion and splitting the nodes if necessary. The fourth one is called the B boxes intersect, which checks if two bounding boxes overlap or intersect each other in the 2D space. The fifth one is called the choose leaf, which finds the best leaf node in the R tree to insert a new point. Moving on, the sixth one is called the split node, which splits an overflow node into two, redistributing the points and adjusting the tree. The one after that is called the calculate B box, which calculates a bounding box that encompasses all points in a list. The next one is called the calculate area, which calculates the area of a bounding box. The one after that is called the adjust tree, which adjusts the tree upwards from a modified node, potentially causing further splits. Moving on from there, we have the combined B boxes. So this basically combines multiple bounding boxes into one that encompasses all of them. Then we have range query recursive, which recursively counts points within a query's bounding box in the R tree. Next one is called the choose seed, which chooses 2 points with maximum spatial separation to start a node split in the R tree. And lastly, in this class, we have the choose next point, which selects the next point to distribute during a node split in the R tree. Now, I've defined more functions. So this one is called the read points, and the next one is called the read queries. So these are basically helper functions that read points and queries from text files and return them as a list of tuples. So the text files are right here, data.txt and queries.txt. Then I've defined a function called sequential scan, which counts points within a query's bounding box for all queries using a simple sequential scan method. Now, I have also defined the main function. So this basically executes the code. It reads points and queries, performs a sequential scan, builds an R tree, performs range queries using the R tree, and writes the results to a file called results.txt, which is right here. And this is the output that was generated. So to summarize, the code begins by reading points and queries from text files, then performs a sequential scan using the sequential scan function and records the time taken. After that, it builds an R tree using the R tree class and inserts the points into the tree. It then performs range queries on the tree for each query and records the time taken for each query. Finally, it prints the total time taken, average query time, and writes the results to a file. So this is the output that the code generated. So what we can infer from this output is that it shows the R tree implementation is significantly faster than the sequential scan approach. The R tree took 13.1 seconds to process all the queries, while the sequential scan took 2.1 seconds. The average query time for the R tree is 0.06 seconds compared to 0.01 second for the sequential scan. This demonstrates the efficiency of the R tree data structure for range queries. And the output generated in the txt file is as follows. This is the txt file that was generated. And that's it. Thank you so much for listening.